Yeah, good evening, everyone.
Good
So,
evening, sir.
today we'll complete GG biplot and then we'll revise ME and GG both. So, we'll start. So, this graph is visible. Oh, I think.
Yes, sir.
Yeah, now it is visible. Yeah, so
Yes, sir, it's
this
now
is this is our first graph we have generated from GGE biplot method. So what is GGE? GGE is representation of genotype and genotype into environment interaction. That is called as GGE. So now here you can see like all the genotypes are distributed throughout the 8 environments across 2 principal components. Right. So here first principal component is explaining 60% of variation and PC2 it's 17. So together they are explaining almost 78% of variation. Right. So here you can see genotype performance as well as the interaction. Both are visible. So here, like same, we have seen in AMI, environments are represented by long vectors. Instead of blue in AMI, here genotypes are represented by red color. Right. So here you can see environment 6 and environment 8. So environment 6 and environment 8, like, and here environment 4. So these 3 environments are having long vectors. So what is the meaning of that? If any particular environment representing by long vectors, then what is the meaning? What you will interpret? Yes?
The difference between the environments.
they have less and less.
What relation? Yeah, anyone else? This environment E6,
This
E8, E4. Yeah.
we can say like that these environments are highly variable, drastic kind of. They are
Yeah.
not stable.
Difference.
Yeah.
Difference
So-
more. So different.
So that means they are having strong discriminatory ability. Okay. So likewise, in contrast, just you can see environment E3 and E7. They are having shorter vector. So that means their discrimination is very
Less.
limited. Very limited. And apart from when we will see all 8 environments, we can see like E4. E4 wants to roam alone. So it is like you go somewhere, I will I don't want to be with anyone, so that E4 is far away from other vectors. So, can anyone tell for what purpose we can use this E4 environment?
If we want to evaluate a genotype, like they can grow in highly harsh environment, something.
Yeah, yeah.
Then-
So, if we have germplasms having variation and we want to select something out of that, so it is better to evaluate in the environments like E4. So from there, we can easily distinguish among those genotypes. So for that purpose, we can utilize these environments. And as far as the genotypes are concerned, so here you can see this AMS MB 5-19, simultaneously this 9305 and this 731. So they are farmost from the origin. So what is the interpretation? How will you interpret it?
They are least
If they
stable
are far
genotypes.
from the origin, yeah,
Least stable genotypes.
across all the environments, but it may be stable with respect to some specific environments. So like that, we need to interpret. But on the other hand, if you will see 1667, MACS 1667, then 139 and 1095. So see, here it is 1667, 139, 710 also it is there. So these 3-4 genotypes, they are very close to origin. So that means across environment they are, yes, this
Stable.
all 3-4 genotypes close to origin means across environment they are stable.
Stable.
Yeah. So if you will see JS335, JS335. So where it is located?
Near to PC.
So just see the axis. Yeah, near to PC2, but just concentrate on the values. Whatever the values written on X and Y axis, so just you can concentrate on the values. And just think what you can interpret with related to JS335.
Maybe not suitable to any environment.
Why?
Because it is far away from the origin, and like E3 vector is in this direction, but it's not close enough.
Yeah. So, like this, you can interpret this graph. Those same interpretation pattern is same. Those who are close, those genotypes close to origin, they are stable. Those genotypes stable across environment. Those genotypes are in the line of vector. They are specifically stable with respect to that particular environment. And those are roaming alone. So that genotype is having poor adaptability across all the test environments. So like example is here in this case, it is JS335. So as we have seen, environment E6, environment E8, environment E4. They are discrimination. They are the highly discriminative environments. So you can use this kind of environments in selection of genotypes. Right.
Hello, sir.
Madam.
Sir, you said that E4 having a longest vector. So genotypes from that environment are more diverse. Yes, sir.
Means,
Shows more
yeah.
variability, but
Ah.
showing more variability means they are not stable, no, sir.
Yeah. But apart from this stability, the same genotype you can evaluate for selection of any particular gene. Means suppose if you evaluated 25 say genotypes and any one genotype performs better, so you can select that particular genotype for your crop improvement program. So I am not saying like you can consider E4 in your stability experiment.
Mhm. But
So
they
it
are
is,
showing
I am,
more diversity because of there is a more environmental effect is more in E4, no, sir. So
yeah.
when environmental effect is more, then how can we go for selection?
So normal, if suppose we have some breeding lines or germplasm lines, so from that germplasm set we can evaluate the madam in that kind of environment.
Okay. Hmm.
So if we will evaluate the set of germplasms, so from that we can get some result, so that it will be better to advance it. For advancement, it will help us.
Okay.
Excuse me, sir.
Yeah.
Sir, can you interpret JS 335 in relation to PC1 and PC2?
So see, that is my question. I asked that question, but what I am expecting the answer, still I am expecting it. I am not getting.
Sir,
So
maybe this
see,
genotype is negatively correlated.
that's what, because see, PC2 on this X and Y axis, both sides values are,
Negative.
yeah. So this JS335 falls in the negative side of principal components. So because of that, it indicates the poor adaptability across all the environments.
So, but it is good for E3 environment.
No, E3 vector is very short. E3 vector is started origin and nearby origin only it will end.
Yes, sir.
Sorry, Prof. Can we have the same interpretation for MAUS 614 since it's also below -10?
Yeah, but see, suppose 0.95 and 1. So whether that two values are different or you will consider as same value, 0.95 and 1.0. Generally, don't see the diagram. General question I am asking. So you got my question. What I am trying to ask?
No, I did not get it, Prof. If you can.
Okay. So
repeat.
suppose there are two values. First is 0.95. Okay. 0.95 and in second it is 1. So both values will be same or different? So just see the chat box. I will type my question. So yeah. So it is like this. You need to interpret this basic biplot. Okay, so then the second is mean versus stability. So what is the meaning of this? Mean versus stability means what? What this graph will tell us? Yes?
Deviation from its mean, sir.
Yeah, so it will consider mean performance along with stability of that particular genotype. Right? So here the PC contributions are there. Then now see, these all are the, you can see the axis. So this axis is called as average environment axis. Whatever the green lines, here it is there. So these lines are called as average environment axis. AEA, average environment axis. It will, what is the purpose of this? It will rank the, whatever the genotypes are there on the basis of their mean performance across the locations. Clear?
सर रिपीट करना इस बार.
So, whatever the green lines are there, this cross mark. So, this cross mark is nothing but average environment axis. It is called as average environment axis. As the name itself indicate average, so this axis will rank the genotypes. This axis will rank the genotypes on the basis of their mean performance. Right?
Yes, sir.
So now, here we need to interpret this. So now, in earlier graphs, we were concentrating on origin. But here, we need to concentrate on this average environmental axis. So, whichever the genotypes are closer to the arrow end of AEA. So now, what is meant by this arrow end? Can anyone? Arrow end means what? Arrow end of particular axis.
Vector, sir.
Vectors are not there. Only we have average environmental axis, and on that basis only we need to interpret it. So what is meant by this arrow end?
Increasing value towards this side.
So just observe the axis only and just tell me if you can observe the arrow end. Arrow end means what?
So till that point only it will exist.
Okay. So here you can see this one.
Sir, in
Yes, sir.
Yeah. What is the meaning of that?
Maybe
The
it
value
is
is
giving the
increasing from
direction.
left to right.
So that axis is moving from left to
Right.
yeah. So that
also
point
moving-
that
It's also moving from left to right, but if we think about the principal component, so one part is the starting, it's like nearby the positive size of PC2, and when we go about the arrowhead of second
no,
part,
this side only, madam. Don't see the left side, right side only. That left side genotypes we will interpret separately.
okay, sir.
Yeah. So this arrow from this, so this axis is going towards right side. So just see this right side axis from origin and tell me how many genotypes are there on that axis. So here genotypes are written in blue color with the dotted line. So that dotted line with genotype name, it is total considered as a genotype. So see KDS 1063. 1059A. So whatever the genotypes are there in the direction of arrow and axis. So all those genotypes reflecting superior mean performance. So whatever these genotypes are there, all those genotypes are are showing superior mean performance.
And what about there is one genotype MAU3 something is in on the line, so on the arrowhead line. It means it's more stable or what? More performing?
No. It is just like from this graph, we are saying like which genotypes are having high in superior performing genotypes across the environments.
Sir, it is
So
both side of the line, or in the upper side of the line, the genotypes will be considered.
near the arrow end axis.
Yes, sir. Near the arrow end axis, the upper portion of the of the line will be considered, or the
whatever the genotypes are connected to this arrow end axis, one dotted, that each and every genotype are connected to this arrow end axis with dotted lines.
okay. That means
Excuse me, sir.
both all the lines, both sides.
Yeah.
Excuse
Yeah.
me, sir. I have one question. Like, what the blue dotted line showing? Like, is this any implication of the length of the dotted line? Because some are
No,
on
no,
the
no, no.
arrowhead. Some genotype
Like in AMI we have seen. I will show you that AMI. Yeah. So here we have seen, na.
Yes.
So same it is like that. It is just that diamond with dotted line here. But here in this case, here it is. Yeah. And here it is in this case, just it is the dotted line connecting with this axis.
Okay, so there is
Yeah.
we cannot conclude anything with the length of
No,
this
no, no.
dotted
From
line.
that, no.
Okay,
From that dotted line, it is not possible to conclude anything.
okay, sir.
So similarly, in this case also, see this JS335. JS335, then all these genotypes, they are on the opposite end. So whatever the genotypes are on the opposite end of arrow end axis, they are showing low mean performance. So just this graph is ranking of genotypes on the basis of mean performance across the environment across this arrow end axis. So it is like just ranking of genotypes on the basis of mean performance of 8 environments. So whatever in the direction of arrow end axis, they are superior performer. Whatever on the opposite end of the axis, they are showing low mean performance. And regarding stability, so now mean performance we have seen. Now one side completed, now versus stability. So now see this 139. It is visible 139.
Yes, sir.
Yes, sir.
Yeah.
Yeah.
So what is your opinion about this 139 and KDS 992?
So these
Whether
are
it
close
is
to origin.
It will be more
whether it
stable.
is why?
Yes, or near the origin.
They are more
Yeah,
stable.
it is near the origin and having less deviation from the axis. It is near, these genotypes are near to origin and having less deviation from the axis, indicating that it is performing consistently across all the environments.
The less deviation, how can you conclude the dotted length?
Excuse me, sir.
So, Dr. Saab, it is simple. If many members are standing close to you, means they are having good communication with you. If members are standing apart from you, they are not correlated. So see, these genotypes are located close to this origin and other genotypes are deviating it. So instead of concentrating on these dotted lines, just see the position of genotypes. Because what will happen now, if you will someone will increase or decrease the dimension, so again you will get confused. So better concentrate on position of genotypes.
Okay, sir. Okay.
Yeah, someone is asking something. You can ask.
Excuse me, sir.
Yeah. Speak up.
Sir, as per my understanding, the dotted line will indicate the stability, I think, sir. The length of
No,
the
but what I'm not saying to concentrate on dotted lines now. If you will increase or decrease the dimension, so again that will create confusion.
okay, sir.
So better to concentrate from this name. You can conclude that which genotype is near to origin and which is far from the origin. So from that you can say, like, as we have interpreted in earlier graph, these dotted lines were not there, but still we have interpreted like which is stable and which is not stable. So like that you can continue. Otherwise, small confusion, it will be problem total. So better concentrate on names.
Excuse me, sir.
Huh.
This vertical average mean axis is there, no, sir. What is, according to that, what we can interpret? Everything
what
we
I'm
are
telling.
connecting only with the horizontal axis, not the vertical one.
Which one is vertical? Which one?
This vertical green line.
So this complete is axis, and if that's what I'm saying, madam. This is the arrow end, means arrow is going, this whole axis is going from left to right. So whatever the genotypes are present on arrow end, they are having high mean performance. Whatever the genotypes are on opposite axis, they are having low mean performance. That is only the conclusion.
Sir,
So in early graph, here also we have not. So here also we have concentrated on center of origin. This is positive, negative side, positive side. Like that only. Here we are saying this is this whole two lines are called as arrow environmental axis. So on that basis only we need to classify these genotypes. Firstly, we will interpret on mean performance, and then as far as the stability is concerned, whichever genotypes are near to origin, those are more stable, as they are having minimal deviation from this arrow end axis. That's why they are considered as a consistent performer across the environments. Yes, Raj.
sir, that genotype MAUS 710. Sir, it is located on the vertical line of that PC1, but how can we correlate it with sir, average mean that line, sir, that green line, sir?
Just see where it is connecting. Check, zoom that diagram and see where this 710 is connecting, or where it is located, whether in the direction or on whether on the opposite side.
Sir, it is on the
Excuse me,
opposite
sir.
side.
So
Excuse
if
me,
it
sir.
is on the opposite side, it is having low mean performance. That's why it is not purely on the opposite side like 725 and 71, but you can consider it as an average. Yeah, madam.
Excuse me, sir. Sir, I have one question regarding the genotype. MAU, some number is I think 3. It's on the horizontal
On
line.
which side, madam? Right side, left side?
Right side, like there is one genotype on the line, the horizontal line that is coming from left.
This one.
Yes, sir.
This one.
So what? Yeah,
Yeah.
what can we say? It's highest mean performing, but
This
it's
is,
far
yeah, this
from
is,
origin.
no, it is far from origin, no problem. But it is in the direction. So we are not saying it is stable. We are saying it is superior performer
Okay, sir. And
because of high mean value. We are not saying all those genotypes are distributed far from the origin are stable. Still, we are
Okay, sir.
stick to our statement. Whichever genotypes are near to origin, those are stable. Our statement is fixed.
Okay, sir. And what about there is one vertical line, green color vertical line in this graph? It's
Yeah, this total cross is considered as that environmental axis. So the direction is like this.
okay, sir.
Excuse me, sir.
Yes.
Sir, from this whole graph, if we have to select some genotypes, then KDS 992 will go best because it is stable and also superior.
992 and 139. Both genotypes are near to origin.
That's why they are stable. But KDS 992 is superior performer.
Hello, sir. Max
that
1067. Max 1067 is also near to the zero axis. So it is
10?
also max 1667. It is near to the horizontal line, sir. Near to zero. And
Yeah.
also having higher performing. So it is also stable
Yeah.
genotype over the across
From
line.
those three, four environments, 3-4 genotypes, you can say like this 992 along with these two genotypes as it is in the direction of arrow and axis and near to origin. So high means superior performer and more stability.
Yes.
Sir, for MAUS 731, we have to say that it is like less stable but having high mean performance.
So see, these ranking are based on mean performance. Again, I am saying in direction superior performer, opposite direction mean value is low. That's why located on opposite side. So this is mean versus stability. So then here next is anyone remembers the name of this diagram? So this diagram is title is which one where. So that means
Sir, I think
Which genotype plot is not visible?
Yes, sir.
No, it's not visible.
One minute, one minute, one
Not
minute.
visible, sir.
sir, it's same as mean versus
One,
stability.
1 minute, 1 minute, 1 minute, 1 minute.
Okay, sir.
Yeah. So this plot will tell you which genotype is stable or which genotype is adapted to which environment. Right. So here X and Y axis, just you can see the PC. So it is covering 78%. And most gene to E interaction covered by first two principal components. So now here we have two things. Environments are distributed, genotypes are distributed, but some connected structure view is there. Likewise, we have seen in AMI2 biplot, here also some connected view is there. With some, I think, 1, 2, how many genotypes are there? 9305, 335, 9705, 9752. Then 70 is 1068 and then 1059.
8 genotypes total, sir.
Okay. So this view is called as polygon view. This polygon view, as all these genotypes are at the corner, and in that corner rest of the genotypes are there. So you can see no one genotype is present outside this polygon except these 7-8 genotypes. Right? Correct or wrong?
Yes, sir.
Yes, sir.
Yeah. So first of all, this view is called as polygon view, which include all these genotypes like 9305, 9752, MX, X70. So what it will suggest? Anyone?
So these 8 genotypes are not stable across the environment.
So if I want this statement in some positive direction,
So they
statement
are
is
highly
correct.
variable.
Huh?
So they are highly variable.
Yeah. So
And they are
likewise, if
good
you
for
want to interpret it, so you can interpret like whatever the genotypes are there in those, means on the line of the polygon, those genotypes are more responsive. And those genotypes are mostly are contributed strongly to the gene to E interaction. Am I correct?
Yes, sir.
Yes.
Yes.
So what I am telling is, whatever the genotypes are on the verge of this polygon, those genotypes are more responsive, and those genotypes are contributed strongly to the gene to E interaction. So that's why they are at the corner. And then what about the genotypes those are present inside the polygon?
They are less
Yes.
significant. Less significant.
Less
They are more
significant
stable.
are less are their contribution to G into E is less. Less significant means, if you will say less significant means, you need to discard those. And if you can see 725, 71, 614. So here you can see these environments are out of the polygon. We'll come to that, but just first see. Genotypes are there inside the polygon, but environments are not there except E7 only, no? Yeah, E7 and E3. Even E5 is also out of that polygon, E2, 6, 8, 1. And where is that lonely fellow E4? Yeah. He is creating his own path. So, the interpretation for this graph is simple. Whatever the genotypes are present inside the polygon, they were relatively more stable. Right? So listen first the statement. Whatever the genotypes, those are present inside the polygon, they were relatively stable. But they are not suitable for any specific environment. Is it correct? Any environments are there? Any environment is there near 731? Here environments are represented by black diamond. So just see, any environment are there near 71, 725, 731?
No, sir.
Yes. Yeah.
No, sir.
Yeah. So in this graph, you need to interpret genotype separately and environment separately. In previous graphs, what we did, we are interpreting genotypes with respect to environment. But here, you need to interpret genotype separately and environment separately. So, what is my starting statement is, whatever the genotypes are present on the verge of polygon, they are more responsive and they are contributing strongly to gene to E interaction. Okay, so this first statement is clear.
Yes, sir.
Yes, sir.
Yeah. Secondly, what I told, whatever the genotypes are there, forget the environment, E3, E7, forget it for 5 minutes. Just concentrate on the genotypes. Whatever the genotypes are present inside the polygon, they are relatively more stable. Okay. So like 667, 1520, 731, 614, they are relatively more stable, but they are, means you can't interpret like 731 is adapted to E3, MAU that 2014-1 is adapted to this environment. It is not like that, though they are relatively more stable. Okay, so this is the first part of interpretation. Now, secondly, that MAUTS70, one of the genotype on the verge of polygon view on right side. If it is visible for you, is it nearer to any environment?
E1.
E1.
Yeah. So that genotype you can interpret like MAUTS70 will be is best adapted to E1. Simultaneously, if you will see, ten KDS 1063.
E5.
E5 environment.
Right. Yeah. Then
MACS 1667 also in E5, then better. The below KDS 1068.
Is it what Dr. Saab is telling, whether it is there or what?
Nearer to
It is
E4.
near E5 environment, but it is more stable. But we are looking for the best, more responsive genotypes here.
Don't merge the different graph interpretation. Like means, sir, we have did the interpretation like that in first graph. So why we are changing? So each and every graph is different. Each and every graph is having its own concept. That's why if the concept is same, then why to interpret all these 7-8 graphs? One graph is enough. Like in AMI, we did 2 graphs. We have we have pack up our bag and we start over. So here in GG by plot, whatever the data you have, whatever the genotypes you have, they are their visualization differently with different concept. So here, whatever the genotypes are inside the polygon, they are not like the genotypes you can say like it is adapted to particular environment. Why I am saying KDS 1063? It is very close to that and it is on the verge of polygon. As whatever the genotypes are there on the verge of polygon, we are concluding like they are contributed strongly to G into E. So that's why I told 1063 only, it is adapted to E5. So any other genotype are there?
No, sir. No, sir.
Okay. So then, now what about environment E2, E6 and E8? They are positioned far from the origin. That how we need to interpret those three.
So none of the genotype can be used for crop improvement program among this environment.
I want to your ask with respect to genotypes is okay. With respect to environment, I am asking.
More unstable environments, sir.
Make it in positive direction, madam.
So can you
Make
repeat
your
the question?
my question is,
G into
we
interaction.
need interpretation of environment 2, 6 and 8.
These three environments are contributing more towards the G into interaction.
Okay. Then they discriminate in those environments. Variation
Genotypes
will be
are more.
So these
Yeah.
three environments are correlated.
Yeah, so variation in all these three environment will be on higher side because of the contribution is more into G into E interaction.
And can we say that like in the genotype that is good for E6, E8, if it's good for E6, then it will be good for E8 and E2 or not?
Yeah, but like if it is like this, but at present genotypes are not there. So
Yes.
we are interpreting with respect to environment. And second question is, how will you interpret E3? E3 and E7.
So E7 environment is almost stable, but favorable for all the genotypes.
So
Because it is at the origin.
So whether if I will say E3 and E7 are the most representative environment. Means more stable environment, is it? because
Yes.
of it is close to the origin.
Yes, sir.
Yeah,
Yes,
and
sir.
again now again, if likewise we did earlier interpretations, so what is your opinion with related to KDS 992? If I'll tell I want interpretation with respect to both genotype and environment, then how will you interpret this 992?
Sir, it is least influenced by the environment.
So
Very
whether you
suitable.
can interpret,
Very,
yeah, Dr. Sir.
so very suitable for E7 environment.
Is it?
Sir, it will be released to two environments.
So it will perform
Yeah,
across same all
that's
the
why
environment. It
that's
is
why
very much less
that
influenced by the environment.
itself that genotype is close to origin. So that means it is the most stable genotype of your lot. In each and every graph of GG, you will find that genotypes are most nearer to the origin. Is it?
So can we
Yes,
say
sir.
can we say that KDS 992 perform stable across all the environment, like even E6, E8, E2, and the far most something E4?
Yeah.
Is it
On what basis? On what basis? The location of presence of that genotype nearer to the origin.
origin near to the
So
origin?
you can cross check here also. This is E7 and this is KDS 992. So here also E7 KDS 992.
And in this genotype into environment interaction is very less.
Yeah, that's why it is stable.
Okay.
That G into E is less. That's why we are saying it is stable. So if we'll consider both adaptability and stability, then which genotypes are there? So same like 992 is there. You can say like 1667, like what you interpret in earlier graphs. So same interpretation if we'll consider adaptability and stability.
So KDS 992 will be stable and best adapted to E7 environment.
Yeah.
Whereas if we talk about
So
MACS
actually
16,
you can say like this KDS 992 is the most stable genotype in your lot as it is having minimal effect of interaction. That also you can say. Because in each and every graph you will find this 992 is very close to the origin. So this next is quite designing. It is very good. So this next is visible discriminativeness.
yes, sir.
Yes, sir.
Yeah. So our next is discriminativeness versus representativeness. So here you will see genotypes, environments, vector. Again, this representations of vectors you will find similar across the graphs. E6, E8, E4, E3, E7. So this discriminativeness versus representativeness. So what it indicates? It indicates the usefulness of each genotype, usefulness of environment for genotype evaluation. So like I told in earlier graph, in earlier interpretation, like the some genotypes having more variation, some environments where you will find more variation in your genotype. So that environment is suitable for evaluation of some germplasm sets or other breeding materials. So this discriminativeness versus representativeness, what they are indicating the usefulness of environments for genotype evaluation. So again, you can interpret like the PCs. PC1 is 60, PC2 is 70. So total, the interpretation is almost 78. So both these are explaining the maximum amount of variation. So then, same thing you can interpret like environmental vectors. Some are less, some are more. They are indicating the discriminating power or the amount of variation in that particular environment. Then just observe the environment E2, E5 and E8 and E6 also. Those 3-4 environments, 2, 5, 6, 8. They are having more discrimination as they are far from the origin along with E4. So among for vectors, this interpretation will be same. So all these 3 environments, 2, 6, 5, 8, these 4 environments is suitable for evaluation of genotypes. And you can identify out of your 30, 50, 100 lot which genotype is specifically adapted to that particular location. So for that purpose, these 4 environments will be useful. And now you will say like, sir, you have just told 4 environments. What about E4? So what about E4? What is the difference?
In fact, I wanted to ask, what about E1?
Less desired.
Sir, that environment is highly variable and not suitable for the evaluation of the genotypes.
Yeah. So E4 is you can't say like E4 is the representative environment. E4 is not representing anything. It is far from that lot.
Excuse me, sir. In this graph,
1 minute, madam, just 1 minute. Okay, now you can speak.
in this graph, we can we are saying about genotype and environment. Both we can say was their discriminativeness and representativeness. So for the genotype, those who are near the origin, they are representative, and those who are on the farmost circle, they are discriminatives, something. And the environment, those who are like their vector lines are close to the origin, like E3, E7, they are representative. And the environment lines, like in the group E6, E8 2 are like discriminative, but the E4 is the most discriminativeness. Can I say like that or not?
But what I'm saying is, so I told like environment E2, even you can consider E1, 2, 6, 5, 8. So all these 5 environments, those are far from the origin. So these 4 or 5 environments you can use for identification of specific adapted genotypes.
Yes.
And why I am not selecting E4? Because E4 is high. E4 is, yes, anyone? Just now someone told the answer about E4.
Sir,
It is not suitable for the evaluation of genotypes
Because
because it is highly variable.
yeah, because E4 is a highly variable environment. So if any environment is highly variable, that environment will not give the actual performance of the genotypes. So maybe your results may be misleading. So better to avoid that environment, and these 4 or 5 environments you can consider for selection of specific genotypes.
Okay, sir. So we keep E4 like in aside the group when we are saying about the discriminativeness and representativeness.
So it is nowhere near anything.
Okay.
So now just the environment E3. It is close to origin, so less discrimination. So so my question is whether E3 will differentiate the genotypes as compared to E1 or E6?
no, sir.
No.
No, sir.
No.
Yeah. So that's why, because E3 is very close to the origin, E3 and E7. So we are saying like both E3 and E7 are the representative environments of our lot. And on the other hand, if we are coming now to the genotypes, so see, whatever the genotypes are nearby the origin, means though it is not exactly, but somewhat near, like this 80 is there, 992 will always be there. Whenever we will use this data, 992 will be there. Then this 139, 1667. Okay, so they are consistently performing. Here genotypes interpretation will be there, but instead of interpreting like which environment is stable and which environment is not stable, we need to interpret environment like which environment is suitable for specific selection of genotype. So likewise, we need to interpret the environments.
Sir, please repeat the interpretation for E3 and E7.
Same interpretation. They are located near to origin, so they are the representative environments. And on the other hand, whatever the genotypes are there nearby origin, though it is 0.5 centimeter away from origin, 1 centimeter or 2 centimeter, whatever nearby origin with minimum distance, so those genotypes you can consider as a consistent performer. Right?
Okay, sir.
And is there is any use for E4, or simply we can discard that E4 environment?
So we can discard it because no genotype is lying near close to that particular environment.
If any genotypes were there, then
So then that genotype may be suitable to that, may be adaptable to that particular environment.
yeah.
Use for the crop.
And on the other hand, as already I told you, E3 and E7, you can consider it as a reliable reference environment for adaptability, as they are close to the origin and they are the most stable environment. Here, next graph will clear your thing. That is, next is ranking of environment. So again, this axis is there. What is the name of this axis?
Environmental.
Average environment axis.
Average.
Yeah, it is average environment axis. So this ranking of environment, it will provide the usefulness of each environment, as already we have discussed this. So usefulness of each environment for selecting superior genotypes. So these concentric circles are there. So here you can see the concentric circles are there. And environment, and here representations of environments are there. So in this you can see environment E1.
Superior and stable. High mean performance.
So we need to interpret this. So concentric circles are there and environment E1 is very close, or you can say that is closest to the center of the concentric circle, followed by E2, E6, E8. Correct? Here don't consider origin, here consider center of concentric circle. So if we will consider the center of concentric circle, first environment will be E1, second environment E2, then E6, E8. So these are indicating like these environments are most desirable. As we have already told, E1, E2, E6, E8. So same interpretation is there. These four, even you can take E5. These but these four are near to the center of concentric circle. So these four environments are most desirable for evaluation of genotypes. Right? Then, apart from these four, now we'll consider next two. So which are the next two?
3 and E7.
E5 and
E7.
Yeah, E5 and E7, they are having moderate distance from the ideal environment. So here ideal is E1, which is present close to the center of concentric circle. Here we are discussing about environment. So E5 and E7 both are having moderate distance from ideal environment. So you can consider both environments are useful. So here you can consider both environments are useful, but less efficient than E1 and E2. But still both environments are moderate, as it is having moderately distance. So you can consider those environments. They will give you meaningful information, but it is not like as E1 and E2. Okay.
Sir, is it because most of the desirable genotypes with more plant height are more means they are found in E1 and E2? Most of the desirable genotypes.
Yeah, for this ranking, madam, it will consider the average performance of the environments. So likewise, you are telling, so performance, yeah, it will consider the average performance of the environment, not genotypes. So on that basis, this ranking will be there.
Yes.
So on the other hand,
so there is one environment which is on the left hand side of the central vertical axis. Only one environment E3, and rest of the environment is on the right side.
So I have completed up to E7. Let me complete.
Okay.
Yeah. So E1, E2, E6, E8, they are the close to the center of concentric circle. They will give the most meaningful information. After that, E5 and E7, they will give meaningful information, but not as good as E1 and E2. So then you can see the two environments, they are far from the origin. So first we will take E3 and E4, they are far from ideal environment. Right? So E3, you can consider like it is somewhat nearer, but E4 is far from the origin. So making E3 is less effective. E3 and E4, both you can consider as a less effective in distinguishing the genotypes. Right, as it is far from E3, more specifically we'll talk E3 first. E3 is far from the origin on either side, on other side of the axis, so it is not suitable for selection of specific genotypes. And E4, it is located extremely at the lower axis, that is least representative. So this kind of environment, as many have answered, so this kind of environment like E4, it will be only useful for selection of specifically adapted genotypes. So from all these 8 environments, if you want some precise interpretation, it is simple. Environment E1, E2, and E6 and E8. So 4 environments are there. So you can say like these 4 environments are most reliable and ideal environment, from where you can get the actual and meaningful results of multi-location trials. And E4 is least informative. So this is ranking of environments. These 4 are nearer to center of concentric circle. So that's why we concluded like they are most reliable and most stable. Then E5, E7, they are moderately reliable but less efficient than these 4. E3, though it is somewhat close, but it is less effective. And E4, it is present on the lower axis, so it is suitable for the specifically adapted genotypes, if any. So likewise, ranking of environments. The next is ranking of genotypes. So ranking of genotypes across the environments. So this will allow the identification of most stable and high performing entries across the your test environments. So here also you can see some concentric circles are there. So that I will come to that point.
So repeat what it is used for.
Ranking, heading is there, ranking of genotypes across environment. It will useful for selection of stable and high performing genotypes. So here, you can see So likewise here, as we have interpreted for environment, the environment located close to the center of concentric circle. So that environment we are saying it is most reliable, right? So here, can you see the concentric circles?
Yes, sir.
Yeah. So now tell me the genotypes nearer to the concentric circle.
710 1666.
1666.
MACS 1666.
MAUTS 70. MAUTS 70.
Okay, you can consider it.
KDS 1. KDS नहीं.
So
KDS
whatever
106.
MACS 1667.
whatever the genotypes position close to the center of concentric circles, so they are considered as the most desirable genotypes of your lot. Whatever the genotypes close to the center of concentric circles, those genotypes are considered as most desirable. Okay. And another thing is, and those genotypes, now you have listed, those genotypes are very close to the center. And again, in next step, you need to select those genotypes are moderately close to the center. First step is close to the center. Second is moderately close to the center.
AMS
And
2000.
third one is far from the center. So first is very much stable. Then the second point, moderately stable. And in third type, it is the genotypes are having poor stability and below average performance across the environment. So it is, first is close to the concentric circle, they are the most desirable. Those who are moderately close to the concentric circle, they are the moderately stable, and those are far, they are having poor stability. So which genotype is located far from the center of concentric circle?
JS 335.
Yeah. So that genotype is consistently in ME also, it is unstable, and throughout the GG also we are saying it is unstable genotype.
Least
Stable, unstable. So that is how the ranking of genotypes. And then this plot is called as relationship between environment. As already we have interpreted this, that environment 1, 2, 6, 8, they were oriented in similar direction, So they are positively correlated and their discrimination is also consistent. And so these environments can be useful for multi-location trials. So then E3, E7 are close, so more stable. Then E4, it is unique, but it is far from the origin far from the origin, so that environment is not considered as a representative environment. It will suitable for the selection of genotypes, those who are adapted to that specific environment. So likewise, this environmental interpretation. So these are the all 7 graphs of GG biplot. With its interpretation like AMI I shared, so the document for GGE also I will share to you so that it will be helpful. And I will share that AMI GG blurb one paper I shown to you. So that research paper I will that also I will share. So you can correlate that values with interpretation. Then our next part is blurb. And after that blurb, instead of going for heterosis combining ability, we will start the genome-wide association and QTL mapping, because it will take some more time. So it's better we will start that genome-wide association and QTL mapping. So it is having many more things. So if in less time it will be difficult to cover. So this is what we have seen from basic biplot up to the relationship between two environments. So total 7 biplots we saw. So here some power issue is there. Yeah, so anyone is having any difficulty or any confusion, any question on this GG? Or anything else you want to discuss, just you can discuss.
So, excuse me, sir.
Yes.
We do like I think 7 plotting, and then in
Yeah,
this plotting we divide we are doing studying the interaction of G into E
yeah,
with different genotype.
yeah.
And after all the analysis, we decide which environment and which genotype is good for our study, like crop improvement program.
Yeah.
Okay, sir.
So likewise, we interpreted like E3 and E7 are the representative environments of our lot.
Yes.
While environment E1, E2, E6, E8, they are the better, they are the ideal environment for selection of genotypes.
Yes.
And E4 is least effective environments, and it is not useful for selection of genotypes, but it may be useful for selection of only for adapted genotypes.
Okay.
And
So,
as
So I like this is the description what we saying with the GGE plot. So
Yeah.
we did ME, GGE, and then we do blob, and then we combine all the analysis, and then we say what's the outcome of our study.
No, no, you can interpret the individual graph separately and finally you can conclude the conclusion. What we are interpreting, like these two environments are representative, these four environments are ideal for genotype selection, and this one environment are less effective. So likewise, and as far as genotypes are concerned, 992, 1667, 139, 1063. So likewise, you can enlist these some genotypes. As the genotypes are located close to the origin, so these genotypes are more stable.
Okay, sir.
So
So
likewise, at last, you can interpret the conclusion.
okay, so I want to like know we did GG plot, we did
Yeah.
ME, and we have one more analysis blob we do.
Yeah.
So we do all this analysis for genotype into environment interaction, like a stability study. Am I
Yeah.
correct?
Yeah.
Okay. So for the regarding the research paper what we do for publishing, do they need like analysis with these three, or then in like one is also good
No, no,
for?
no. What we used to do, na madam, generally for stability analysis, our first character, irrespective of crop, max 99% our major criteria is yield. Yield
Yes.
and yield contributing characters, we will study the stability. Okay. So in that paper, what we used to do, we will represent whatever the graphs we have seen, AMI stability, AMI by plot, GG by plot, and BLUP graphs also we will represent for, first we will represent all this for yield. Yield only we will concentrate.
Okay,
And
sir. Yes.
in blobs, we used to we used to present the yield graph along with yield and contributing traits. So if you have 8 traits, but just we are focusing main on yield. What is the
Yes.
effect? What is the multi-environmental effect on yield?
Yeah, yield is the main criteria for this.
Yeah,
Like usually it's
no need to represent these 7 graphs of each character. So here it is, we are considering 8 traits, 8 into 7, so 56 graphs will be there for only for GG.
yes.
Yeah, so better to concentrate on your trait. So if you will see the research papers also, you will come to know the same pattern is there.
Okay, sir.
Yeah.
Okay, sir. Thank you, sir.
Hello, sir.
Yes.
Sir, along with grain yield, if our target rate is like a shoot fly resistance, dead
Yeah,
hard, or
so then according to the objective, you need to change your representation pattern.
yeah, for 2 traits can we go, sir?
Yeah, you can go. You
Okay.
can go with shoot fly also. If any diseases are there, you can go with the diseases. So means you can study the multi-environmental effect on that incidence of that disease, and what is what is the effect of those on grain yield. So like that you can interpret the paper.
And for other characters, what we have to do, sir? Only
So
analog we
only
can do.
generally whatever the papers I have seen, generally they are representing other characters in bluff only.
Okay.
Not for this AMI and GG. In AMI and GG, they are concentrating on the major character.
Okay.
Whatever the representation styles as of now I have seen, so from that I am telling.
Sir, is there any limit for selecting the number of traits or yield? Whether
Repeat your question.
Sir, is there any maximum limit for the number of traits to be selected for ME and biplot analysis?
You can study, but that's what I told. If now we have 8 characters, we have 7 graphs per character. So whether any journal will accept 56 graphs in any paper?
No, sir.
So that's why whatever you can search the ResearchGate, Google Scholar, whatever the websites are there, so you will find like they are concentrating on their major character, and they are visualizing other traits in blobs.
Okay, sir.
Hello, sir.
Yes.
Sir, for the conclusion part, do we combine all the results of these 3 stability plots or separately we do?
No, from all the 7 stability plots, we have concluded like E3 and E7 are the representative. These 4 environments are ideal for selection. E4 is less. From all
Yes.
7 plots, we came to this conclusion.
So that is based on GG. What if
Yeah.
we will conclude the AMI and BLUB in the same paper?
Yeah. In ME also we concluded from those 2 biplots, we came to conclusion, and with BLUF also we will come to conclusion from the stability parameters we got. And this graph, this we will start tomorrow. I will show this graph to you. Yeah, this graph. Again, this is the ranking of genotypes, and you will see the different colors. And below the principal components. So here you can see the 7 principal components with eigenvalue and accumulated variance.
Okay, sir. Thank you.
So these are the graphs. Whatever the graphs I am saying, that in papers for yield and yield contributing characters, so this type of graphs are there.
Excuse me, sir. Sir, I have one question regarding augmented analysis. So, in augmented analysis, we have two kind of data. One was the yield one, and other was a qualitative data was there. So for yield, I know the dependent trait is yield and other traits are contributed. But when we go for analysis with the quality trait, like iron, there was iron and 2 or 3 trait. Okay, so how can we say which one is dependent trait on the
For means which analysis you want to do? Normal augmented
it
only,
was a
or
augmented
any
one.
correlation or anything? Any
No,
other
it was
analysis?
a correlation, I think it was, yeah. I was
So
doing
instead
correlation
of
analysis, and at that time I was thinking, but if we want to analyze in quality trait, they all are different.
in quality traits, you can't say like suppose oil content and protein content. So you can't say like I will keep protein content as a dependent variable and oil content and other things are the independent variables. Like yield. Like yield is depend on many factors. So that's why we will tell like yield is our dependent variable.
Yeah.
Okay. So
Yes, sir.
in as far as quality traits are considered, you can run directly correlation. If you will find any correlation, suppose oil content in some cases you will find like correlation and oil and protein having negative correlation. So in that case, it is not like that. Like some is dependent or some is independent. So they are all different.
Yes, that all the traits are different. We know for the grain yield, like it depend, but we don't know about the quality.
For field observations, especially for grain yield or fruit yield, you can say like fruit yield is depend on many other factors.
Yeah, many other parameters. Yes, sir. But if we can say the thing like little bit, we can say in quality trait for like grain length and something for some parameter, but not for the, there was a 3 parameter and that's
You
that was the
can't
total.
say like whatever the factors you are telling, it is not like it is responsible for all the quality traits.
Okay, sir.
So for tomorrow, what we will do, we will first finish bluff, then we will revise all the 3 models again. Tomorrow we will finish this stability chapter, and from day after tomorrow, we will start this molecular chapter like genome-wide association, what is HapMap, how to arrange phenotypic data, what are the models available in our studio to analyze this genome-wide association study. How many plots we will get, how to interpret it, how to see, where to see the whatever the MTAs are there, marker trait associations, how to see the marker position, how to annotate the markers. So there are a lot of things. So each one by one we will see.
Sir, in short, can we also have the analysis of augmented RCBD data? So what are the plots coming in that particular for each trait? Can we analyze that, interpret it?
Okay.
Sir,
Just remind me tomorrow.
Okay.
Sir, for block
Okay, sir.
analysis, I have a query because in my previous company they did block analysis with single replication. Is there any way out to do that? I don't know.
For what? For what purpose?
For selecting genotypes means best performer across the location. The trial was there, so to identify the best performing genotypes.
So maybe experimental design will be different. Maybe they use different experimental design. But because if you have single plot, so you can't say like one replication.
I think they used to different blob model. I don't know, but single replication they used to do.
Yeah. But their basic work for plotting the experiment, their experimental design must be different.
Okay, so can you
for
share some model for that so that I can apply?
That different bluff models we will see in molecular part. That is, some are bluff, then blue is there.
Yes, sir. I bluff and blue they also used it.
Yeah. So that part that part will come during molecular work that we are starting from day after tomorrow.
Okay, sir. Thank you.
Sir,
Yeah, that part will come, sir. No problem.
Okay, sir.
Sir, that normalizing about data and sir, Eberhardt and Russell model we will not study.
So Raj, for you now, I will share that Mantle test script.
Okay, sir. Yes, sir. It would be very helpful.
Just run with your data, because in my exam, whatever I am sharing the data, there is no need to run any test. So just you can try to run that test and just share me the result. I will share in group so that it will be useful for everyone.
Okay, sir.
Sir, Eberhardt and Russell model, sir.
That script I will share tomorrow. I will show once and then I will share.
Okay, sir. Thank you, sir.
Sir, if possible, kindly teach me how to analyze alpha lattice design also. Sir.
Alpha lattice script is there. Okay. No problem. Script is there. So we can show that. Alpha lattice and split plot. If anyone is having split plot also.
Hello, sir.
Yes.
I have sent you that Excel codes and I reminded you. Can you please share that?
Okay. I will share that.
Thank you.
Okay. So tomorrow we will finish this stability chapter. And from day after tomorrow, we will start our new chapter, molecular breeding chapter. So maximum, we'll finish it before this Dashera 2-3 days time. Because in that Dashera 3-4 days, no one will get time to attend. So it's better in that Dashera time, we'll keep this close. Because bachelor people will go home, family persons will be busy in work. So before that, we'll try to cover maximum this molecular breeding aspect. Okay. So tomorrow we will complete this chapter. Meanwhile, I will share the Mantle test script and normalization script and Eberhardt and Russell model script with you in WhatsApp group.
Okay, sir. Thank you.
Okay. So just Eberhardt Russell script is simple. Just try to run it. If you will face any error, then we are here. No problem. Yeah.
Thank you, sir.
Yeah. Okay. Thank you.
Thank you, sir.
Because of this power issue today, we will close this session 15 minutes early. Okay. So we'll meet tomorrow 6:15.
Thank you, sir.
Yeah. Thank you.